Welcome to Ask and Learn.
We want to produce the graph of f that reveals all of the important aspects of the curve, where f is x to the fourth minus x cubed minus 8 all over x squared minus x minus 6. And we want to use the graphs of f prime and f double prime to estimate intervals of where the function is increasing, decreasing, any extreme values we may get, intervals of concavity, and inflection points. So, just for the sake of keeping the video as short as I can, I went ahead and already found f prime and f double prime, and I already graphed all three of these functions. So the first graph I have over here for f of x, that's just what it gave me when I plugged it into my graphing calculator. And I mean, that looks like a pretty nice graph, and you might, when you first put this in there, say, oh, that's all I need, and kind of be on your way. But if we use a little bit of calculus, we can see that this viewing window isn't the best one we can actually use. So let's go ahead and start looking at our first and second derivative graphs. So I went ahead and on my graphing calculator found or estimated the x-intercepts here. And these values will all be critical values that we're going to use, and we can use the fact of where our function is greater than 0 and less than 0, the derivative, to figure out where the function is increasing and decreasing. So I'll just kind of do this off to the side here. So we know a function will be increasing if f prime of x is strictly larger than 0. So let's just go ahead and figure out what those intervals are going to be. Now, these red dotted lines I have in both of the graphs are vertical asymptotes, because if you were to go ahead and factor the denominator, we should get x minus 3 and x plus 2, meaning x is equal to negative 2 and x is equal to 3 will be vertical asymptotes. And I just went ahead and put those in there to make sure we don't try to say that it's increasing from negative 2.745 all the way to negative 0.807. All right. So our interval of increasing. So we first become positive, like I was saying, at negative 2.745. And actually, let me write this a little bit neater. So at negative 2.745. And we're going to stay positive all the way to our vertical asymptote, which is going to be at negative 2. Then we're going to union, and it seems that we are coming down also positive from our vertical asymptote there. So it's going to start from negative 2 again, and then go all the way to negative 0.807. Then we're going to be negative until 0.411. And then that'll last until 1.82. And then we're going to union that one last time with 4.059 to infinity. All right, so that's a pretty long interval, but at least we found it. And even better yet, we just got to estimate that as opposed to having to solve it by hand. All right, now for where it's decreasing, we want f prime to be strictly less than 0. So to the left of our first point, we are negative, so negative infinity to negative 2.745. Now union. Then we become negative again after negative 0.807. And we stay negative until 0.411. Union with. And then we're going to be negative from 1.082 all the way into our vertical asymptote at positive 3. And then it looks like we start off at it being negative on the other side of that vertical asymptote as well, and then we go all the way to 4.059. All right. Now, let's go ahead and figure out if these points are maxes or mins as well. So normally what we would need to do is to also check where our function is undefined. Our first and second derivatives are undefined for critical values. But in this case, it's undefined at x is equal to -2 and 3, which our original function is also undefined at. So we don't need to worry about those being critical values. And we can just look at these 5 points that I have listed here. All right. So to the left of this point here, we are negative, or we're decreasing. So we're decreasing into the point and then increasing after. That means this is going to be a local minimum at x is equal to -2.745. Then, for our other one, we're increasing and then decreasing. So that's going to say we have a local max there. Our next point, we are decreasing because we're negative and then increasing after. So that tells us we're going to have a min. And over here, we're increasing and then decreasing. So that tells us we have a max. And for our last point, we're decreasing and then increasing. So then we have a minimum there. So we know whether these 5 points are maxes or mins. So now let's go ahead and look for the concavity of our function. So at least these intervals won't be as bad. So let's just go ahead over here. So we know that a function will be concave up when f double prime of x is strictly larger than 0. So let's go ahead and see where that is. Now, it looks like to the left of our vertical asymptote, we will always be positive. So from negative infinity to our vertical asymptote at -2, union, and then we're positive again between -0.388 to 0.79. And then on the other side of our vertical asymptote, we're also positive, so from 3 to infinity. Now we want to go ahead and check for where it's concave down, and that's just going to be the rest of our interval, or where f double prime is strictly less than 0. So that's going to be starting from our first vertical asymptote, so -2, and we're going to go until -0.388 union with, and then after 0.79 all the way to our next vertical asymptote being around 3, or at 3. All right, so we have our concavity. Now, for our two x-intercepts here, notice that they both change from being concave up, so our first point goes from concave down to concave up, so that means this here will be a point of inflection. And then the other one goes from concave up to concave down, so this is also a point of inflection. All right, so now that we have those points, those important points, I went ahead and found out what these values should be. So these bottom two are our inflection points, and these top values will be all of our maxes or mins, or local maxes or mins. So now the viewing window I chose, at least for the x value, was -4 to 5, and my rationale behind that is when I was looking, I saw that my largest value was about 4, so I knew I wanted to be slightly to the right of that. And the smallest value I have is about -3, so I knew I wanted to be the left of that. So one thing I did was I also kind of zoomed out really far just to make sure I didn't miss any x-intercepts or anything like that. And luckily for us, I didn't. And so that's why I'm on that x interval. And for the y, I just went ahead and found that my largest value was going to be about 30. So I just went a little bit larger than that. And then I just went below negative, or even though I don't have a negative value and my smallest one is about 1.2 here, or about 1.3, I just went negative so we can also show these intercepts that we get a little bit nicer. All right, so this is a really nice viewing window for this function, and we can clearly see that we have our vertical asymptote at x is equal to -2, and not as good for x is equal to 3, but it kind of looks like it. We see where we have our concavity, all of our maxes or mins, and all the little dots on this graph, I should mention, are the local maxes, mins, or points of inflection. And we can see how it kind of changes using this viewing window pretty well.